Okay, I'm assuming that you've read the problem, so we're going to define the variable first. We're going to let x equal the number of hamburgers and y equal the number of hot dogs. Okay, once that's done, now we got to go to writing equations. Now, part we get confused at is the dollar amount is what we're going to use last. That's going to come into play down here when we are trying to decide what our profit is. So right now we're going to ignore that part. We're going to go back to hamburgers and hot dogs to stay in business. We must sell at least 10 hamburgers. That means X has to be greater than or equal to 10, but not more than 40 hamburgers. That means X has to be less than or equal to 40. Goes on to say it must sell at least 30 hot dogs. That means Y has to be greater than or equal to 30, but cannot cook more than 70, means Y has to be less than or equal to 70. The snack bar cannot cook more than 90 items total. Right there, that means our last equation, X plus Y, has to be less than or equal to 90. Okay. And I guess I probably should have had those equations down here. I'm missing a step. What are the constraints? Right and graph these. So all of these should be down here. So now we got a graph, but before we can graph, remember we got to define these things. We know that our X values down here were hamburgers. Okay, and we want to also label the x-axis, and I'll do it in terms of 5s or 10s. And then the y-axis is the hot dogs. And we'll label that in terms of 5 each line. Okay, the question, can we sell half a hamburger or a hot dog, is clear no. We're not going to cut those in half. Got to sell a whole one. We've also now got to graph these things. So let's go ahead and graph them. In green, I've got a vertical line at x equals 10 and everything to the right. And then x less than 40 and everything to the left. Then y greater than 30 is here, means above that, and y less than 70 and below that. Okay, and then one more, got x plus y less than or equal to 90. That implies I've got y-intercept of 90 and x-intercept of 90 and a line that comes through those 2 points. So let's go ahead and plot that. Missed it. Let's fix that. All right, so, and that we're going to test if I plug in 0, 0 is 0 plus 0 less than or equal to 90. That's true. So we're going to shade below that line. So my area of this is going to be between the greens, below and above the blue, and underneath the purple. And we end up with this section right here. What we're looking for specifically are the intersection points to maximize profits. And we've got 5 points there. We've got 1030, we've got 4030, we've got 4050, we've got 2070, and we've got 1070. All right, the equation I would use goes back up to those first two numbers I said we're not going to use till later, 33 cents and 21 cents. So that means 0.33x plus 0.21y is going to give me my profit. Okay, so how many of each item? Well, now we've got a test, and that goes back to those numbers right there. We got to test them all, 10, 30, and I'm going to list them all. Okay, so those are my 5 numbers. Remember, those came from the intersection points up there. And now I've got to test my equation, and that equation, remember, is coming from this one up here, right there. So we need to plug in 0.33x plus 0.21y and find out what that equals. And I'm going to let you plug those numbers in. I bet you can plug those numbers in. I'll give you the totals, and we'll run with that. Okay, so those are my totals, and like I said, I'll let you plug that in, you guys. That's 0.33 times 10 plus 0.21 times 30 equals that. And you can go through that and figure it out. The question is, how many do we sell to maximize profit? And I think that's clear. My maximum profit right there is 2370. So we're going to sell 40 hamburgers and 50 hot dogs. And we're done.